This video covers Lesson 9-3 for Secondary 1 Math, Congruence. Warm-up 9-3. Determine which congruence test, if any, can be used to show that the two triangles are congruent. If the triangles are congruent, write a congruence statement. If not, write NEI, which means not enough information. Now remember, we have three postulates that we can use to prove that two triangles are congruent. Now the first postulate was the side-side-side postulate, meaning if they have three pairs of congruent sides, the triangles are congruent. The second option was side-angle-side, and this was if we have a side, a pair of sides that are congruent, then angles that are congruent, then sides that are congruent, in that order, we can say that the triangles are congruent. And the last one was angle, side, angle. So, number one, we have the triangle DAT and the triangle DET. And it looks like we have one pair of congruent corresponding sides, a second, and this third one is also congruent since they share that side of the triangle. So we can say that triangle DAT is congruent to triangle DET by side, side, side. Okay, number two. So we know in number two that EF is congruent and corresponds to QR. We also know that angle R is congruent to angle E. But that's all the information we have. And we can't prove anything based on just two congruent corresponding parts. So this is NEI, not enough information. Number three. So we have first this side with the two tick marks, which is B to C, is congruent to DC. Then we have an angle, we start making our way around the triangle, which is angle C in both of these. And then we have a side, AC and EC. So this is side, angle, side. So we can say that triangle ABC is congruent to triangle EDC. So again, triangle EDC. And that's by side, angle, side. Number four. Prove whether or not triangle LMN is congruent to triangle TUV using side, angle, side. So first we're going to write down all the information we're given. So here we have LN is equal to, if we look over on the triangles, LN is 45 meters. So we're going to write 45 meters. Okay, MN is on that same triangle. The other side is 28 meters. The side length TV is on the other triangle now, 45 meters. Next, the measurement of angle N, well, that's a square there, so that means it's a 90-degree angle, so we'll put 90 degrees. Now the measurement of angle V is in the other triangle, and that's also 90 degrees. And the measurement of TU, which is in that second triangle, is 52 meters. So we're just identifying this from the two triangles given. So the next thing we want to do is we want to figure out what the length of UV is. And the reason we want to figure this out is because we have some corresponding congruent sides. We have LN, which is congruent and corresponding to TV. We also have these angles. So angle N and angle V are also congruent. So we have side, angle, so we need another side. And we know that NM is 28 meters. So if VU is 28 meters, we can state that by side, angle, side, these triangles are congruent. So we need to use the Pythagorean Theorem and find the length of UV. So the Pythagorean Theorem states that the two shorter sides, so 45 squared plus, we'll say b squared, is equal to 52 squared. Now, if we square those two values, we get 2,025 plus b squared is equal to, I'm having a hard time fitting this, but it's 2,704. Then we're going to subtract the 2,225. And we get that b squared equals 679. So 679. Then take the square root, and b, or the length of UV, is approximately 26.05. Now, how much we round it, it is what it is. But this is not exact. This is about, so I'm going to make the squiggly line here, 26.05. The exact value would be the square root of 679. Okay. Now, what we're going to do is we're going to compare these. So we got ln, which we have in red, is congruent to TV. So we'll put TV here, also in red, in our triangles. Then we have angle n is congruent to angle V, also in the triangles. Then we have mn is congruent to UV. But that's not true because UV has a length of 26.05 units, and MN up here has a length of 28 units, or meters. Sorry, these should be in meters. Those are not the same. So this is false. These are not congruent. Put a slash through that congruent sign. Okay? We really can't say UV. We have to say it's not congruent to this. It's none. It's not congruent to any other side. So our conclusion is that triangle LMN is not congruent, so we do a congruent symbol with a line through it, to triangle TUV. And the reason is because MN is not congruent to UV. So satisfying that we can prove that these are not congruent. Okay, number 5. Let's prove whether or not triangle FHG is congruent to triangle VXW using side, side, side. So first thing we're going to do, can we figure out any of these lengths? So let's start out with FH. I'll highlight this in blue, FH. Well, the nice thing is this is a vertical line segment, so we can count. 1, 2, 3, 4. So this is going to be 4 units. So I'll just put 4. Next, VX. Well, VX is nice too because that's a horizontal line, and that is also 4 units long. Good sign. Now HG. HG is not a horizontal or vertical line. So we're going to have to use the Pythagorean Theorem or distance formula. Now I prefer the Pythagorean Theorem, so I'm going to show you the Pythagorean Theorem. I created a right triangle from H to G, and I find the side lengths. This one's 1, the other side is 5. So writing this with the Pythagorean Theorem equation, we say 5 squared plus 1 squared equals C squared. And C represents the segment HG. So anyway, 5 squared is 25 plus 1 squared is 1, so it's 26 is equal to C squared. Then you take the square root. So C is going to be the square root of 26. Or HG is the square root of 26. Now let's go check that with XW. So we're thinking XW. So XW, if I draw a right triangle, we're going to have a side length of 1. The other side is 1, 2, 3, 4, 5. Notice they have the same side lengths on that right triangle. So the length of the hypotenuse will be the same length. So we're going to say this is the square root of 26. Then we're going to go ahead and find that third side length. So FG, drawing the right triangle, we have a side length of 3 and a side length of 5. So this would be 5 squared plus 3 squared is equal to the hypotenuse, c squared. That's 25 plus 9, which gives us 34. So c squared would equal 34, and c would equal square root of 34. So we're going to write square root of 34. We're not going to worry about simplifying this radical expression. Now let's look at VW. So drawing again that right triangle, we get a side length of 3 and a side length of 1, 2, 3, 4, 5. And again, they match. So we know using the Pythagorean Theorem equation that the hypotenuse of this right triangle is the same as the other right triangle. So FG has the same length as VW. So this would be the square root of 34. Now, notice that we have the same lengths here. So we know that VX, the segment VX, is congruent to the segment FH. And we know that the segment XW is congruent to the segment HG. And the segment VW is congruent to the segment FG. So, because of this, we can say that the triangle VXW is congruent to the triangle FHG. And the reason that we can say that, based on the information we have, is the side-side-side postulate. Okay, that concludes the warm-up. So lesson 9-3, more about congruent triangles and actually writing the proofs to prove that these triangles are congruent. So we're going to keep referring back to the side-side-side postulate, the angle-side-angle postulate, and the side-angle-side postulate. For each of these proofs, we're going to want to make sure that we state all the given things in our box that we're given. Okay? And we're also going to want to mark them on the figure in the top right corner of our screen right now. Okay, the triangle ABC and the triangle ADB, or ABD. Order matters. Remember that. Okay, so given, we know that the measurement of angle C, so write that down here, the measurement of angle C is equal to 105 degrees. So I'm going to go to angle C and I'm going to write down 105 degrees. Now, we also know that the measure of angle BAC, so BAC, that's this one here, is 45 degrees. Okay, so the measurement of angle BAC is equal to 45 degrees. We're also given the measurement of angle BAD, and BAD would be this one here, A being the vertex. This is 45 degrees. So the measurement of angle BAD is 45 degrees. And the last thing is that the measurement of angle DBA equals 30 degrees. So that's this angle right here. This angle here is 30 degrees. All right. So step 2 in our proof. Looking for a reason, it says the sum of the angles in a triangle equal 180 degrees. Well, in both of these triangles, we know 2 of the 3 angles. And if their sum is 180 degrees, we can just take 180 and subtract the 2 other angles in the triangle. So minus 45 minus 30. Okay, so this would be, carrying that 5, that would be 105. So we know that the measurement of angle D is 105 degrees. Okay, we can do the same thing with our other triangle. We have the 45 and the 105. So if we add those together, that might make a little more sense to us. If we add these together, we get 150. And if we take 180 and subtract 150, we get 30. So we would say that the measurement of angle CBA is equal to 30 degrees. Step 3. Congruent parts have equal measures. Okay, so ASA. So they're telling us we want to use angle, side, angle. So if we want any of the sides to be the same, the only one we know that can be the same is the one that is the same side or same line segment, which is AB, using the reflexive property. Something is always congruent to itself. And so that's going to be the segment AB, okay, is congruent to the segment AB. Now we need to get the congruent corresponding angles on either side of this line segment AB, or the side of the triangle AB. So the angles with the vertex of A and then the angles with the vertex of B. So the first pair, we'll use angle BAC. Okay. So BAC is this angle here. It's also here in our given. And we say that that is congruent to angle BAD, which is also in our given. And we know that those are congruent because they have the equal measures. Now, the other angle is going to be over with B. So we're going to have angle DBA is congruent to, think about it, DBA, angle CBA. That's one of the ones we found, knowing the sum of the angles in a triangle equal 180 degrees. So now we have angle, side, angle. So we can state that triangle ACB is congruent to triangle ADB because, our reasoning, angle, side, angle. All right. Our second proof. Given C is the midpoint of AE and BD, prove whether or not triangle ABC is congruent to triangle EDC using side, angle, side. So they're telling us what to use. Side, angle, side. All right. So the first thing we got to recognize is that it said C is the midpoint of AE and BD. That's what we're going to write down here where number 7 is. Now that we've written down our given statement, C is the midpoint of AE and BD, let's make sure we understand what that means. If C is the midpoint, that means it's the same distance from A as it is to E. So AC would be the same length as CE. So we can use tick marks to show this in our triangle. AC is the same length as CE. Also, since C is the midpoint of BD, we can say the same thing there, that BC is the same length as DC. So we have a pair of congruent corresponding sides, another pair of congruent corresponding sides. We can say, by definition of midpoint, AC is congruent to EC, or segment EC. Now, by definition of vertical angles, this is super important for us to remember. Vertical angles are these. Those that are across, kitty corner, we could say, okay? Not next to, not adjacent. So we can say that angle DCE is congruent to angle BCA. Number 10, segment BC is congruent to segment DC because DC, remember, has the two tick marks as does BC. And that's by our definition of the midpoint. They're the same length. Because we have a pair of congruent sides, then a pair of congruent angles, and then a pair of congruent sides, in order, we can say that triangle ABC is congruent to triangle EDC by, for the reason, side, angle, side, or the side, angle, side postulate. This concludes the video of Lesson 9-3 for Secondary 1 Math, Congruence.